Hey everybody, thanks for joining us. We're going to talk today about how we at Vanguard tried to not only make open source consumption safer, but also faster and easier for our developers. Our goal is, if you're from a regulated company, that you take away from this some things you might do to improve the developer experience for open source consumption for you. If you have not been hurt, then I am happy for you. And maybe what you can take away from this is these are like the hoops that we're jumping through at regulated organizations just to consume open source. So that's sort of what we hope you take from it. A little bit about us. I'm Brando. This is Greenwood. Brian works in our developer experience organization. I am recently departed from the developer experience organization and have joined the security organization. So I'll blink twice to let you know I am still okay. It's only been about 3 weeks though, so time will tell. Both of us have been at Vanguard for a while. Vanguard's a really interesting company. It's been around for a while. If you know us, you may know us because we popularized index funds. You may have retirement dollars with us, a lot of folks. We're kind of an interesting company because our mission statement is as simple as what's on the slide here. It's a very sort of take care of the clients kind of a culture. And it's also an interesting thing. I gather we're like ownership structure-wise as close to being an open source company as I've seen. We don't have private ownership and we're not publicly traded independently. So like if you own the index funds, you own a piece of the company and those are the only people that own the company. So the only incentive is to do better for clients, which is what has kept me there for 17 years and interested in doing it. We are a financial services company, so like we like numbers, we like big numbers. The important ones to take from here is like, hey, there's a whole lot of assets that are behind our software, and there's a whole lot of us developer-wise. It's just a lot of people. There's about 5,000 developers, which is a whole lot. The stuff we'll talk about serves all of them. We've been doing it like 50 years, so there's some software that's about that old, which is as fun as it sounds. And we are in a regulated industry, as I said. So some companies may not have to take the risk of the license exposure or security vulnerabilities as serious as we do. But we're not having that luxury. We have to take it very seriously. So a lot of what we're going to talk about is how we do it safely, not just how do we do it in ways that are easier, faster. You'll see that because of this, we start in a place where we're just sort of coming to the terms with the fact that our company uses open source software. We didn't sort of openly admit it. We use most of our dependencies through our application server providers that were proprietary. My friend Frank here asked me why we would have trouble admitting it, and I'm glad you did because it helped me to sort of think on it and figure out how to explain this to somebody that's not in a regulated industry. If you are, you already kind of get this because you deal with it every day. If you're not, optimistically it might be, or sort of pessimistically, it might be about just executive fear. We're a financial services company, so folks are very comfortable with the idea that like, hey, I interact with people by giving them money and them signing contracts, and that's how I know they'll do work for me. And open source isn't that. Sort of on the more optimistic side, this might be about our ownership structure a little bit. There's like a whole lot of money there, and all that money is tied to the client owner's financial goals. And if we mismanage it in any way, there's not like a private board or a Wolf of Wall Street who can take a bath on it. It's just everybody's retirement dollars. So in the best of ways, maybe the reason we're afraid is because we're really concerned for our client owners and we want everybody to have financial success. All right, so we're going to walk you through what is sort of our journey to use open source safer, easier, and faster over about 12 years. So we'll start way back and work our way through the phases I've got on the slide here. And let's get it started with where we started, which is with internal package registries. So a lot of companies, when you start using open source, you just build against a public package registry. You go out to NPM, you go out to Maven Central, you pull down the dependencies you need, and that's where you start. We didn't start there because of all the concerns I'm talking about. So where we started was with an internal package registry. So we built our own pool, And in our own pool, only we have peed in it. So to use the analogy of the day, that's sort of why. So what does that look like? We introduced continuous integration at the same time. So folks went from a paradigm where maybe when I was new to a project and needed to build it for the first time and I noticed I was missing dependencies, I might go like, hey, Brian, where does that thing live? Can you tell me about it? And sometimes he would tell me about like someplace I had to go and submit a request to have software installed on my computer. Maybe he'd tell me about a network drive, or like sometimes he would be like, Brando, shh, I'm gonna send you an email in a minute. You copy it onto your hard drive and say nothing and it'll just work. So the black market of dependency acquisition was sort of where this was taking the place of. So we went from that to, hey, everything's going to be built on a CI server. That means you can't be procuring it, whisper down the lane, Brian sort of cold handing off to me in my cubicle. Rather than that, you're going to have to go against the internal package registry. At the network layer, we blocked the public ones, so this is how we knew sort of where dependencies were getting sourced from. And then the CI server was going to build our releases. Our releases were going to get put into the internal package registry, so we've got our own little dependency universe built out here. This was around 2012 when we were doing this. We got declarative dependency management, like I said, really good, and adopted the CI paradigm. For us, it looked a lot like this. So here you can see there's two of the internal package managers that we use today. We only used one for starters, and it looked a lot like the public package manager does. You know, you can go and browse the contents of Maven Central just like you can browse the contents of our Nexus repository. Now we have a bunch of languages split out across these two. That's sort of where we stand today. So the move from like sort of the in the dark, we don't know what we use, and ostensibly none of it's open source, but like really it was, is this approach with just using an internal package repository easier than it was prior? Yeah, for sure. Like having declarative dependency management is a lot easier than having ad hoc dependency management or no dependency management. So it's a whole lot easier for me to figure out how to satisfy dependencies without having to like whisper down the cube row to Brian to figure it out. But what's really kind of bad about it is at this point, like because the internal package registry was new, we weren't very good at running it. And we didn't know sort of what was in there was curated by somebody. Nobody kind of knew who, and why things were allowed to be in or not allowed to be in was sort of a mystery. And so that didn't make it very easy. If what you needed wasn't in there, or you needed, heaven forbid, a new version of something, you didn't really know even what to do about that, which is not easier by far. This was faster than whisper down the lane, try and figure out what network share I don't have access to, where probably some package is stored that I need. But it's not faster if your package isn't in the registry and you have to play Scooby-Doo about like how does stuff get into the package registry. Was it safer? Yeah, for sure. Like the stuff that we described about the dependency black market is pretty much what supply chain security is all about these days. And we're sort of, today very familiar with like the stuff that can go wrong when that's how you manage your supply chain. So it was definitely safer in that way. It was not safer in all the ways it could be yet. We weren't managing licenses really very well. A person that was like an administrator of the package registry was going to squint at a license and stare at words that they do not understand, and then make a decision about whether or not that seemed like it was open source with only like, the most trivial understanding of what those words meant. And likewise, we did not have a security professional involved, so vulnerable packages, if they were identified, we didn't really have any kind of skill at assessing how severe the vulnerability might be, whether or not that was okay for us to use, or what we were going to do about it. So this was all brand new. You can guess that like the whole idea of like not even knowing how to get new stuff into the internal package registry is the thing that inspired us to move on to our next phase in the evolution of this, which was to actually have some processes around consumption and to actually understand, how things get into the internal package registry and why. So that's where we went next. You can see the paradigm is very, very much the same. The bottom half of the slide didn't change from the last one. What's new is we introduce an artifact request. Developers that need something new in the package registry can submit one of these. That'll get you a package registry administrator to review the thing. And then if the license seems okay, if the security vulnerabilities seem okay, they'll go out to the public package manager, download it, and put it into the pool, hopefully with no P. So that was about 2017 when we got there. So it took us like a solid 5 years to master this. You'll see as we move along in this journey, we accelerate a little quickly after this. We established our first actual open source policy. That was important for establishing the process because it was like, hey, under what criteria is something okay, AKA what is the definition of P. So that was what was in our policy, is like, hey, how do we know if this dependency is okay to go in? We actually, at this point, in order to sort all that out, started to do the things that were really, really missing from the prior paradigm, which is like, hey, figuring out if a license okay should probably involve a lawyer who understands what the terms of that license mean, and figuring out how bad a security vulnerability is probably should involve a security professional. So we did that in, unfortunately, first cut of the workflows was like 3 different workflows by department. So it looked a lot like this. What you can see in the foreground is a request for a dependency. You kind of said what you need from which dependency repo you needed it from, and then some number of days later, out the other end pops the dependency in the internal package registry. So was this easier? Yeah, for sure. It was no longer mysterious how you get something into the package registry. It was kind of clear cut. What wasn't awesome is that if you had a new package you wanted and it maybe had a legal license that wasn't on the list of lawyers pre-approved, and it had a security vulnerability that we needed a security professional's take on, you had to do 3 separate workflows in order to get it into the package manager, and that is not easy. Likewise, 3 separate workflows, all with manual steps, not faster. Was this safer? Undeniably so. This was the gain in this phase, was, hey, this is a lot safer. We've actually got a lawyer looking at licenses who understands the implications of them. We've actually got a security professional eyeballing CVEs and talking about how exploitable or not they are for us. So this was a great move, but it still certainly left something to be desired in the developer experience when you maybe had to follow 3 different workflows and you were the glue that held them all together. So to move on from there, Brian is going to talk to us a little bit about how we automated things from here.
Yeah, and you can kind of see by what was bolded on the last slide is kind of where we wanted to tackle in our next phase. So that was automated consumption. So instead of having an admin upload something to the registry, put some automation in place. So that's a bit quicker. So this is what the diagram looks like in this phase. You can see the admin was replaced by automation. So when the user submits an artifact request, instead of an admin going to the public package registry and doing the validation there, we have some automation within our build system that'll go out and pull it from the public package registry if it falls within the security and legal guardrails that we have defined. So this was about 2018, which was also coincidentally about the same time that I joined the company. We had separate request types per package manager. So if you wanted to download a Python package from PyPI, there was a request for that versus Maven versus NPM. And like I mentioned, all of this happened during the build. So it would perform a download, run rules to make sure it was in our guardrails. If it was, it would add it to our internal package registry. And this helped us scale out to about 10,000 artifacts a year via these requests. So this is what that looks like. In the foreground is like the actual request where the end user or developer has to fill in the information about the library they want to bring in. And then in the foreground is kind of like our automated lifeguard TechBot, which is the automation we wrote, letting the user know like whether or not the automation was successful. So this was definitely easier. It was one simple request and one workflow as opposed to 3. And it was a lot easier to understand. But obviously 0 is better than 1. It was faster because it was better than hours or days it took for an admin to do it previously. But what's even better than minutes, almost instantaneously, or seconds. And it was safer because we did have more formal guardrails and a more auditable trail of what was brought in. And so our next phase was kind of integrating our security and license policies with some of our registry tooling. And instead of operating more like an allow list, allow kind of like everything by default, and then if there's a security or legal issue, throw it out into a quarantine workflow. So a much simpler diagram in this case. We have the public package registries on the left there. When a user runs like an npm install or a pip install, if the package doesn't exist in our internal registry, it'll go out to the public registry, try and proxy it in, and provided it has an approved license and doesn't have any security issues, it'll be in the internal package registry. If it does have those issues, then we throw it out into a quarantine workflow. So we did this in about 2019. Like I said, the internal registry pulls from the public. And really the registry tooling kind of allowed us to enforce governance natively here. There were things we could do within the tooling to define, an approved set of licenses and security configuration that really kind of accelerated our journey here. And then in terms of scale of like artifacts, this like exponentially increased it, obviously, because we were proxying. So the last I checked in like one of our tools, we have 50 million artifacts. Some of that, is obviously internal software that we develop, but a large portion of that is open source packages we pulled in internally. So here's an example of like what the registry tooling looks like. In the background there is how we defined our allowed licenses list. If it's not within that list, obviously, then it gets quarantined. So how the end user sees that, it's when they try and pip install something or Maven install something, they'll get a 403 from our registry saying that it's been quarantined. And when that happens, they have to submit a request, so that's what's in the foreground. As an example of someone submitting a Python request to use the library Pillow. We can't see the comments here, so not sure whether it's a security or legal issue, but when that request is submitted, someone who's familiar with the licensing and the security is the one that reviews that. So there's still a human in the loop here. So it was definitely easier. Most developers really don't know it's there unless they get quarantined. And I would say probably 95% of the packages we pull in are within our guardrails. So it's really only 5% that do get quarantined. But when a developer gets quarantined, then they have to learn kind of about the governance policy. It was definitely faster. It's almost instantaneous, probably just a couple seconds if you're going down the happy path. And it was safer because instead of having the policy in the build, it's in centralized kind of in the registry and is closer to where the open source packages are coming into our environment. And we'd kind of be remiss if we didn't talk about going the other way. So we also revamped our open source contribution process within the last couple of years. Again, a very simple diagram here. Just when a developer at our company wants to publish something to a public package registry, there's just a simple request they have to submit. So we did this in about 2022. Previously, it was a bunch of email approvals that you needed, and we changed this to a ticketing workflow. We were also able to reduce the number of approvals that were needed when we did this, so less approvals that developers needed in order to contribute to open source. We also were able to kind of affect some cultural changes when we did this. Instead of developers being challenged for contributing to open source, they were thanked. And previously, a lot of the open source contribution that we were seeing was for exclusively outside of their employment. So like on the weekends, at nights, kind of sort of not related to what they did at work. But when we made this workflow change, more of the contributions were as part of their job. They were doing it during their working hours, on their working laptops, and they were committing to open source packages that they were heavily dependent on. So this is an example of what one of these contribution requests looks like. This is actually one of mine. And in the background there is kind of the metadata I need to fill out about the open source project I want to contribute to, namely the license and the GitHub URL or wherever the open source package is version controlled, so someone can take a look at it. And then we have our friendly automated lifeguard tech bot helping out here too, letting me know where I am in the process and if there's any other information I need to add to the ticket to help it get its approval. So to kind of summarize how we got from phase 0 all the way to phase 4, a lot of it started out with putting actually budgeting behind some of these processes. So pitching a business case for it, getting leadership, sponsorship, and buy-in from developers. And I think the biggest thing that really helped us was making friends and getting buy-in from our friends in legal and security. And kind of the way we did this was kind of learning outside of our domain. So we got very familiar with like our intellectual property policy, our information security policy, and that kind of helped us to build a good rapport with our partners in legal and security and helped us to get buy-in from them when we need to make process changes like this. And the other thing that kind of helped us, we took you on like a 12-year journey that, the technology obviously changed in between those 12 years. And that is kind of also what helped us kind of accelerate our open source consumption and make it a lot faster and safer. But one of the reasons we're at this conference is we hope that our story is useful to other regulated organizations, but we're also here to learn as well. So we have questions. We'd like help. How do we want to know how other companies are handling commercial restricted packages in their registries? How you're handling use case specific license approvals. For some of those fair source licenses that were mentioned earlier today, how are you handling those? How do you handle container images where there's just a never-ending list of dependencies there? How is your supply chain security journey going so far? Where are you with Salsa, SBOM, Guac? And what are the things that we haven't thought of? What else is even faster, easier, or safer?
So we did leave some time for questions. So please throw them at us, especially on that last one. If you're doing something that sucks less than what we do, tell us about it because we would like to do the same. Yep, hang on. I think you should be hot. Maybe I'm wrong.
Right, am I hot?
No, you're not.
How about now?
Yeah, it looks like it lit up. Try it one more time.
Okay, all right. Got two questions. First one is, for the developers, are the developers allowed to use packages not in your list in a development environment so they can even figure out if they really want to use a package before they go through the process?
I don't think they would be able to, because I think we're blocking the public package registries at the network layer. So they could try and pull it in. As long as it's not quarantined, they could use it. If it is quarantined, they would just have to go through that quarantine workflow to get it approved.
Yeah, in the earlier years where it was just the internal package registry, no proxying and no hope of seeing anything else, we did have more like sandboxy type stuff like you're describing.
Okay.
At the tail end of our journey, we're permissive enough now that chances are, like, if you can't get through the guardrails to try it out, you just can't use that anyway. You're in the 5% of things that's just no good with our policies.
Yeah, and I'm suffering memory loss, and I can't remember my second question, but I'll raise my hand again. Whenever.
If you think of it, yeah, let us know. Anybody?
Just more of a comment. If anyone does have issues with their container scanning, we found that OSV scanner uses Google's OSV database, and they actually seem to read, like Debian's security tracker in order to, reduce down the noise of just simple, hey, dependency version checks. Curl has this vulnerability, but Debian doesn't build it with that option, so you're not impacted. So we found that's a nice way to kind of clean up a lot of our noise in the vulnerability list.
Yeah, that is the thing we're looking at right now. We're using, obviously, a lot of vendor tools that you saw on the slide. Some of them are telling us about features they have to help us with exactly that, like, is this exploitable for us? Right now, that's a manual analysis by somebody in the security org, probably like yourself, that toils away at it. But yeah, we're going to introduce some tooling help for that reason. I'll follow up with you after to get a little more info. Anybody else have questions for us? Yeah, Frank.
So hypothetically speaking, if I were a developer at Vanguard working on, say, the main personal investor portal, and I'm like, YubiKeys are awesome, I'd like to add, it actually exists as a feature. How does that wend its way into that dependency chain being allowed for a flagship product like that?
Yeah, so it depends if you're going to do that with like open source dependencies or not. If it's open source dependencies, the nice thing about the tail end of our journey that makes it easy to use is like the first thing you should do is just try it. So the dependencies that you need, throw them in your dependency descriptor, in your POM, in your package JSON, whatever, and just run your install. If everything is going to plan, you're fitting within the guardrails, you don't fit the definition of P, and so it gets proxied right into the repo, and you don't have to even worry your little head any further about process. If whatever you're pulling in gets flagged, because it's either got a license that's not something our lawyers have blessed or has a, like, let's say a critical vulnerability, you're going to go through the process of submitting one of the requests for us to take a deeper look at it. Usually the first thing we'll ask you when you submit one of those is like, hey, do you have reason to believe that the license is wrong or that this license should be okay? That's what we're going to feed over to the lawyers. So like Brian and I end up being the glue in between. So we'll talk to developers in developerese and then talk to lawyers in like our best legalese we can impersonate. But we'll connect those pieces of information. It's like, hey, we looked at what they sent us. It's a new license, one y'all aren't approving of. Can you now?
I guess a follow-up question. So now we're years past that point, and a CVE has dropped against one of the libraries, but the patch is not on the approved list yet. How does that get worked in an organization like that?
I think it would be pretty much the same. Like they would just try and pull in the new version. As long as the new version comes in fine, they're good. If it doesn't, then they just go through the quarantine workflow again.
Yeah, so we did casually slip in the build failing thing, which is unfortunately a part of our developer experience. But in the beginning of this journey, that was way more common an occurrence. Toward the end of this journey, like we're reserving that for like 9s and 10s on the CVE, so like only your really extreme stuff. It's still going to happen sometimes, and sometimes it will be a false positive. So typically what's going to happen there is like if you end up quarantined, and we do life cycle type enforcement, so you know, our native policy enforcement that's on the package manager, like regardless of whether that package is just entering the package manager or it's been in there for 2 years, when we discover the security vulnerability, our policy will say, hey, you're not allowed to have 9s or 10s. This is going into quarantine now, regardless of where it stands. If that happens to you, sometimes this can be a real problem because occasionally somebody like Frank calls up and says like, hey, I'm quarantined, but I also have an outage right now and it's really bad. And like, I can't be worried about this security vulnerability because I do have a rare priority that's actually higher, which is like I'm down. So when that happens, like our major incident response knows how to deal with that. We make exceptions in those cases. Likewise, you know, if it was not quite as critical for you because you weren't in the middle of an outage, but you were like, hey, I can't possibly fix this for reasons. Maybe there's no patched version of the dependency available. Yeah, so when that happens, what we do is like, hey, you know, not all risks are mitigatable. Some of them you got to accept. So you would go through that same workflow. It would go to a security professional who's going to pressure test, hey, have we examined all the other options? And how bad is this actually? What should we do? But, you know, the option's there for like, hey, we might just not be able to do anything, unfortunately, in which case we're going to take it out of quarantine. Usually when we do that, we give it a shelf life. So it'll come out of quarantine for like 60 days, then we'll check again, see if there's a patch now. Right, we don't block every security vulnerability because like we got a job to do and like they're all right. So like we're reserving the like, hey, like fail a build, don't let anybody produce any software with this in it for like the worst cases. Let me go over here, then I'll come back to you, Lucas.
Hello. Hey, I have two questions. How you manage your end of life for the open source softwares?
What was the question for?
How do we manage end of life for open source software? I'm assuming you're saying package has become unmaintained.
Yeah, unmaintainable, and they say like, you know, that this is discarded after these years, right? So
Yeah.
there
So
should
if
be
you
some-
have an answer for this question, come talk to me after. We sure don't.
I'm trying to figure out.
Yeah, okay. Well, like, yeah, me too.
So my second question is, right, so what you use for your SES scanning is like a proprietary tool, or you have your, you know, inbuilt something?
We do not have any custom in this space.
Okay.
We use a handful of vendors. I'll try not give too many free commercials, but
Yeah.
like we have some stuff from Sonatype, we have some stuff from JFrog,
Okay.
and then we have a handful of other vendors that are doing like not SCA proper, but all sorts of other static analysis. So like with as many developers as we have to have a whole bunch of tools. which like if anybody wants to chat later, come and see me about like what you do about like 50 tools and that confusing everybody about what they should work on, because we certainly had that problem.
Sure. Thank you.
Yeah.
I think that's all we have time for. Oh, maybe one more.
Question. So what is the frequency of updates, right? How frequently you update your internal registry? Is there a policy specific to,
I mean, the registry is updated every day because it's based on, what our developers are pulling in.
Okay.
So, yeah, every day we're probably pulling in, X number of new open source packages and probably rescanning on a cadence there too.
So every time you pull, like you have a workflow where you continuously scan and make sure that, you don't have any vulnerabilities?
This answer was different in the earlier phases when there was some sort of manual action to do updates. Once we get to like the proxying state, the installs of software are what's triggering fresh ingestion from the public package registry and application of the policy. So when we went from like only 10,000 a year, that was when it was manual and we knew exactly how many were coming in and when because we had to do a thing. These days, we don't have to do a thing, so some of it's driven by development team need. When they're upgrading a new version because they need a new feature, that's going to trigger more stuff to come in. If they're using things with dependency ranges and they're just re-resolving their dependencies, in NPM, if you nuke your package lock, you may get new versions. That's going to trigger a flow in. But this is the phase when Brian was saying, hey, we don't count like that anymore because it's just a never-ending flow of new dependencies. So long as they comply with policy, no action taken by a human.
Got it. Thank you.
That is, I think we're out of time for questions, but we will be around after if anybody wants to chat about this stuff or help us with the questions we asked about, just catch us in the hallway. Thank you for your time. Thanks for listening to us, friends.